Okay, so now the next thing that we have here is a couple of examples using all of the properties of the inverse trigonometric functions that we did in the previous two videos. So we said that basically example number 3. Example number 3, you want to show that basically number one, the sine inverse of basically 2x times the square root of 1 minus x squared is equal to 2 times sine inverse x, 2 times sine inverse x, for -1 by square root of 2 less than or equal to x less than or equal to 1 over square root of 2, right? So we have the result over here. That said that the result that we had over here, okay, so we had the result over here that said that basically, so here you have sine inverse of this is equal to 2 times sine inverse of this. So over here we said that, for example, 2 times tan inverse of x is equal to so on and so forth. Okay, let me see. Okay, so they have solved this problem in a very interesting way. I couldn't figure it out, but then I took a look at the solution. So we want to prove that the sine inverse of 2x times the square root of 1 minus x squared is equal to 2 sine inverse of x. So if I said that basically if I let x be equal to for example something like sine theta, right? Then I can say that basically theta is equal to sine inverse of x. Theta is equal to sine inverse of x. Now, since theta is equal to sine inverse of x, so theta is equal to sine inverse of x. So then we have sine inverse of basically 2x times the square root of 1 minus x squared. The sine inverse of this is equal to the sine inverse of then over here x is equal to sine theta, right? So I can write this as the sine inverse of 2 times sine theta, the square root of 1 minus sine squared theta. And now 1 minus sine squared theta, as you know, is equal to cos squared theta. So I can write this as sine inverse of 2 times sine theta, the square root of basically cos squared theta. The square root of cos squared theta, if I can assume that cos theta is cannot be a negative number, then I can if I basically, meaning that, for example, when you want to take the square root of 9, you can write it as plus or minus 3. Now if I can make sure that basically, and if I, meaning that the square root of x squared, I can write it as x being, for example, greater than 0, if I know that x is not less than 0. So which means that I need to make sure that cos of theta is not less than 0. Now cos of theta is, well, now that depends on the bounds that you put on theta and x and so on and so forth. So there is really no good way to decide this. And I mean, there is ways to decide that, but that much detail has not been given in this solution. I'm not going to do that either. So, but of course, whenever you want to write the square root of cos squared theta, you need to make sure what is theta, what is cos theta, whether they can be negative values, positive, and so on and so forth. You already know that. So, so then I can write this as the sine inverse of, basically the sine inverse of 2 sine theta times the square root of cos squared theta, which is the same thing as the sine inverse of 2 sine theta cos theta, right? And 2 sine theta cos theta, and now 2 sine theta cos theta is equal to cos sine 2 theta, I suppose. Let me see if I can find that over here. Number 5, number 4, number 3, number 6, number 7, and we have number 2 here. We have number 1. I think somewhere over here we have, yes. So in the results that we did before, we said that sine 2x is equal to 2 sine x cos x, right? So I know that sine 2x is equal to 2 times sine x cos x. So that means that 2 times sine theta cos theta is the same thing as, I can write this as the sine inverse of basically sine 2 theta, right? Which is the same thing as 2 theta. Now theta is equal to sine inverse of x. So that is 2 times sine inverse of x. Which means that basically the sine inverse of, which means that the sine inverse of 2x times the square root of 1 minus x squared is equal to 2 times sine inverse of x. Well, whether or not you will be able to use this result anywhere, that I do not know, but well, the way that the problem has been solved is actually pretty interesting. Now, the next part of this question is as follows. So you have the sine inverse of, you want to prove that the sine inverse of basically 2x times the square root of 1 minus x squared is equal to 2 times cos inverse of x for 1 over square root of 2 less than or equal to x less than or equal to 1. So again, you can take cos of theta as x. You can take x as, basically x is equal to cos of theta. If you take x as cos of theta, that means that basically theta is the same thing as cos inverse of x. Okay, so what that means is that let me see what we did in the previous part of this problem. So we said that, for example, over there we took x as sine of theta, then sine inverse of x is equal to theta. Then we have the sine inverse of 2x times 1 minus x squared. And if I write this now in terms of x, which is the same thing as the sine inverse of basically 2 times cos theta times the square root of 1 minus cos squared theta. And if I take this as the sine inverse of 2 cos theta and 1 minus cos squared theta, if I take it as the square root of sine squared theta, which ultimately becomes sine theta, 2 sine theta cos theta is basically sine 2 theta. So I can write this as the sine inverse of sine 2 theta, which is equal to 2 theta, right? Which is equal to 2 cos inverse of, which is equal to basically 2 times cos inverse of x, which means that basically 2 times, or basically sine inverse of 2x times the square root of 1 minus x squared is equal to basically 2 times cos inverse of x. That is basically what we wanted to show here. Okay. This was example number 3. Now, example number 4. Example number 4, we want to show that tan inverse of 1 by 2 plus tan inverse of 2/11 plus tan inverse of 2/11 is the same thing as tan inverse of 3/4. So tan inverse of 1 by 2 plus tan inverse of 2/11 is equal to tan inverse of 3/4. So there was a property here that we showed that tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus xy for x times y less than 1. And here we have 1/2 times 2/11 is of course less than 1. So I can use the same property here. Basically, I can say by 5 part 1, we have basically tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus x times y, and that you can use if x times y is less than 1, right? So now, since that is the case, I can say that, therefore I can say that the tan inverse of 1/2 plus the tan inverse of, and basically you need to pay attention to the fact that tan inverse of 1/2 is an angle, right? Because 1/2 is a ratio, you give it to the tan inverse function, it gives you some angle, and again, tan inverse of, for example, 2/11 is another angle, and then you add those two angles together, it gives you another angle. So it gives you some relationship between some trigonometric ratios, and x is nothing but a trigonometric ratio of some angle. Y is nothing but a trigonometric ratio of some angle, and so on and so forth. So the tan inverse of 2/11 is equal to tan inverse of basically x plus y, which is basically, so x here is 1/2 plus y is equal to 2/11, and 1 minus 1/2 times 2/11. So that is equal to tan inverse of, so over here we have what is 1/2 plus 2/11. 1/2 plus 2/11 is equal to 22/11 plus 4, which is equal to 15/20 seconds. 15/20 seconds, and that is basically 1 minus 1/2 times 2/11 is 220 seconds. 220 seconds, I can write it as 22/20 seconds minus 220 seconds, which is equal to 20/20 seconds, which is equal to 10/11. So that is basically 10/11, which means that basically now 15/20 seconds by 10/11 is the same thing as 15/20 seconds times 11/10, and that is a 2, so divide by 5 you will get 2, divide by 5 you will get 3, so that's 3/4. So that's the tan inverse of 3/4, and that is equal to the right hand side of the equation, okay? And that is actually basically your left hand side, LHS, and therefore LHS is equal to RHS. So that is basically example number 4. That is example number 4. Now example number 5. Example number 5, we have you want to express tan inverse of cos x by 1 minus sin x and I don't understand what that means in the simplest form. Okay, so negative 3 pi by 2 to basically less than x less than pi by 2 in the simplest form. Now in the simplest form means that whatever that means. So we said that basically tan inverse of we cannot use any of these, they're not relevant, and they're not relevant either. Cos inverse, and no, not this one. And tan inverse, no, not this one. But we could probably use some of these, meaning that, for example, okay, now to solve this problem, basically you need to make some arrangements here. So now let me explain to you how they have solved this problem. So okay, so there are a number of steps in solving this problem. So first of all, if you want to simplify this, what you can do is that there are basically two ways basically this example has been solved in two ways. The first solution, I didn't understand a couple of steps, so I'm not going to go through that. But you can write basically tan inverse of cos x over 1 minus sin x. 1 minus sin x, you can write it as so cos x, you can write it as basically in the what we derived here was that sine of pi by 2 minus x is equal to cos x, and cos of pi by 2 minus x is equal to sin x, right? So I can use both of these here, meaning that I can write basically the sine of pi by 2 minus x is equal to cos x, and the cos of pi by 2 minus x is equal to sin x. So I can use these two over here to rewrite this as basically the tan inverse of basically cos x. I can write it as sine of pi by 2 minus x, and again sin x, I can write it as cos of pi by 2 minus x. So I have a 1 over here, so 1 minus basically cos of pi by 2 minus x, and that is the tan of this angle. Now basically the next step is that you need to make some arrangements in the numerator and the denominator, meaning that you have to somehow express this in terms of, for example, tan inverse of, for example, tan of some angle x, and then that gives you x back, right? So here I have tan inverse here. I have to make some arrangements so that this becomes tan of something, and then I can take that out, and this whole basically thing is to do just that. So sine of pi by 2 minus x, I can write it as basically we said that sine of 2x, sine 2x is equal to 2 times sine x cos x, right? So that means that sine of, if I divide this angle by 2, I get x, and that is 2 times sine of x divided by 2 cos of x divided by 2, right? So I can write this as the tan inverse of basically 2 times sine basically this angle divided by 2, which is well, if you write basically pi divided by 2 minus x, that is the same thing as pi minus 2x divided by 2, right? So that is pi by 2 minus 2x divided by 2, which is equal to x, so pi by 2 minus x. And if I want to divide this angle by 2, because I have to do it here as a part of this formula, then this, if I divide this by 2, I will get pi minus 2x divided by 4, right? So this angle divided by 2 becomes pi minus 2x divided by 4. And then I have also cos of the same angle, which is pi minus 2x divided by 4, and then the denominator is basically 1 minus cos of pi by 2 minus x. and they have written the denominator as 2 times sine squared of pi minus 2x divided by 4, right? So what that means is that they have written 1 minus cos of pi by 2, 1 minus cos of pi by 2 minus x, which is the same thing as 1 minus cos of basically pi minus 2x divided by 2. That's pi by 2 minus x. They have written this as basically 2 times sine squared pi minus 2x divided by 4, right? Now the way that you can make sense of this is that well, this basically, if I call this whole angle, if I call it x, this angle becomes x divided by 2, right? That means that 1 minus cos of x is equal to 2 times sine squared x divided by 2. So you might remember the formula cos of 2x is equal to, and let me rearrange this formula so that you can see it. So this is basically, take cos to the other side, becomes cos x is equal to 1 minus 2 times sine squared x divided by 2. If I multiply this angle by 2, I will get the cos of 2x is equal to 1 minus 2 times sine squared x, right? So that is basically the formula for cos of 2x. We said that cos of 2x is equal to, basically, it had, I think, 4 different forms, if I'm not mistaken. Let me see. We had basically cos of 2x. We said that it's equal to basically cos squared x minus sine squared x. We had also basically 2 times cos squared x minus 1, and also 1 minus 2 times sine squared x, and also we had it as 1 minus tan squared x over 1 plus tan squared x, right? So that is cos of 2x. Now they have used basically this part in order to rewrite 1 minus cos of pi by 2 minus x as basically 2 sine squared pi minus 2x divided by 4, right? So what that means is that then what remains is basically so this is sine squared pi minus 2x divided by 4. This is sine of pi minus 2x divided by 4. So I can simplify this 2 with this whole part over here. 2 and 2 I can cancel out. And so I have cos of pi minus 2x divided by 4 divided by sine of pi minus 2x divided by 4. Cos divided by sine gives you cot of the same angle. So that is the same thing as tan inverse of cot of pi minus 2x divided by 4, and basically that is basically how we can write it. Now I need to somehow get a tan over here so that I can simplify this. And we said that basically the cot of pi by 2 minus x, we said that the cot of pi by 2 minus x was equal to, as a part of these formulas that we derived here, right? So we said that basically cot of pi by 2 minus x is equal to tan x, and tan of pi by 2 minus x is equal to cot x. We derived these formulas, so you know what I'm talking about. So basically I can say that tan of pi by 2 minus x is equal to cot x. So I can write this as tan inverse of, instead of cot of basically x, I can write it as tan of pi by 2 minus this angle. So pi by 2 minus this angle that we have here. So it is pi minus 2x divided by 4, and that is the tan of this angle, and then I will close this bracket here, right? So now I can write this as tan inverse of basically tan of now pi by 2. Let's simplify this. So pi by 2 minus pi minus 2x divided by 4. I can write it as pi by 2 minus basically pi by 4 minus 2x by 4, which is equal to pi x divided by 2, right? So that's equal to pi by 2 minus pi by 4 minus pi by 4 plus negative into negative is positive, x divided by 2. Now pi by 2 minus pi by 4 is going to give you pi by 4, positive pi by 4, plus x divided by 2. So I can write this as the tan of basically pi by 4 plus x divided by 2, which is the same thing as basically, so we have tan inverse of tan of some angle, which is the angle itself. So x divided by, pi divided by 4 plus x divided by 2. That is the simplest form that you can write this. This basically exercise.